Hello, everyone. Thank you for looking at my poster and listening to this small talk. My name is Jordan Young, and I'm a student at Stony Brook University. I'm going to talk about my project probing aqueous alteration of carbonaceous chondrites via carbonate clumped isotope and Raman carbon thermometry. So the rationale for this project was to assess the conditions of carbonaceous chondrite parent body alteration processes, examine the alteration history of those carbonaceous chondrites and their parent body, and develop a methodology for understanding parent body processes via the study of returned samples from Bennu and Ryugu. Just some quick background, aqueous alteration of carbonaceous chondrites is one of the earliest geologic processes known. Carbonaceous chondrites contain organic carbon and carbonate minerals precipitated from alteration fluids. And the structural properties of organic carbon and the isotopic composition of carbonates can help us better understand the thermal conditions of alteration. All right, so let's talk about some results on the Raman spectroscopy side of this project. Peak metamorphic temperatures estimated by Raman measurements are mainly in the range of 223 degrees to 267 degrees Celsius. There is an outlier to this temperature range, about 355 degrees Celsius, but it's possible that this is due to its status as a highly weathered meteorite find. Now for the carbonate clumped isotope portion of the project. We have initial carbonate clumped isotope data for the CM2 chondrite Murray, and it suggests a carbonate formation temperature of about 10 degrees Celsius. Now, this reported temperature greatly contrasts with the reported value of 30 degrees for Murray by Guo and Eiler in 2007, but we're using different calibrated thermometers. The one we're using is a little bit newer than theirs, so that might account for some of the difference. In conclusion, Raman and clumped isotope measurements both suggest that the carbonaceous chondrites were altered under low temperature conditions. There is a disparity, and what that suggests is that bulk carbonate formation probably occurred after the chondrite parent body had undergone significant cooling from its thermal maximum. With that, I would just like to acknowledge my advisors, sample sources, and funding sources. Thank you.